Tcl is a scripting language created by John Ousterhout, originally born out of frustration, according to the author, with programmers devising their own languages intended to be embedded into applications. Tcl gained acceptance on its own. It is commonly used for rapid prototyping, scripted applications, GUIs and testing. Tcl is used on embedded systems platforms, both in its full form and in several other small footprint versions. The combination of Tcl and the TK GUI toolkit is referred to as Tcl. TK. History. The Tcl programming language was created in the spring of 1988 by John Ousterhout while working at the University of California, Berkeley. Tcl conferences and workshops are held in both the United States and Europe. Features. Tcl's features include all operations are commands, including language structures. They are written in prefix notation. Commands are commonly variadic. Everything can be dynamically redefined and overridden. Actually, there are no keywords, so even control structures can be added or changed, although this is not advisable. All data types can be manipulated as strings, including source code. Internally, variables have types like integer and double, but converting is purely automatic. Variables are not declared, but assigned to. Use of a non-defined variable results in an error. Fully dynamic, class-based object system, TCLU, including advanced features such as meta-classes, filters, and mixins. Event-driven interface to sockets and files. Time-based and user-defined events are also possible. Variable visibility restricted to lexical scope by default, but up-level and up-var allowing procs to interact with the enclosing function's scopes. All commands defined by Tcl itself generate error messages on incorrect usage. Extensibility via C, C++, Java, and Tcl. Interpreted language using bytecode. Full Unicode support, first released 1999. Cross-platform. Windows API, Unix, Linux, Macintosh, etc. Close. Cross-platform integration with windowing interface TK. Multiple distribution mechanisms exist. Full development version Tcl Kitstar Pack Free Wrap Selsh turns Tcl scripts into single-file, binary executable programs. BSD licenses, freely distributable source. Tcl did not originally have object-oriented syntax, so OO functionality was provided by extension packages, such as INCR-Tcl and XO-Tcl. Even purely scripted OO packages exist, such as SNIT and STOOOP. SafeTcl is a subset of Tcl that has restricted features. File system access is limited and arbitrary system commands are prevented from execution. It uses a dual interpreter model with the untrusted interpreter running code in an untrusted script. It was designed by Nathaniel Borenstein and Marshall Rose to include active messages in email. SafeTcl can be included in email when the application, SafeTcl and multipart, enabled mail are supported. The functionality of SafeTcl has since been incorporated as part of the standard Tcl TK releases. Syntax and fundamental semantics. The syntax and semantics are covered by the 12 rules of the Do Decalogue. A Tcl script consists of several command invocations. A command invocation is a list of words separated by white space and terminated by a new line or semicolon. Word 0, word 1, word 2. Word n. The first word is the name of a command, which is not built into the language, but which is in the library. The following words are arguments. So we have command name argument 1, argument 2, argument. An example, using the puts command to display a string on the host console, is puts hello world. This sends the string hello world to the stout device with an appended new line character. variables and the results of other commands can be substituted inside strings too, such as in this example where we use set and expr to store a calculation result in a variable, and puts to print the result together with some explanatory text. #expr evaluates text string as an expression set sum, expr 1 plus 2 plus 3 plus 4 plus 5 puts the sum of the numbers chapter 1, 5 is $sum, with variables. It is faster to protect this string using curly braces. Set x1 set sum, expr $x plus 2 plus 3 plus 4 plus 5 puts the sum of the numbers chapter 1, 5 is $sum, without curly braces. Variables are substituted even before parsing the expression. Set x2 set op asterisk set y3 set res, expr $x $op $y puts 2 asterisk 3 is $res. There is one basic constructor and a set of simple substitution rules. Formally, words are either written as is, with double quotes around them, or with curly brace characters around them, which suppresses all substitutions inside. In bare and double-quoted words, 3 types of substitution occur. Command substitution replaces the contents of balanced square brackets with the result of evaluating the script contained inside. For example, expr 1 plus 2 plus 3 is replaced with the result of evaluating the contained expression, since that's what the expr command does. Variable substitution replaces of $sign followed by the name of a variable with the contents of the variable. For example, $foo is replaced with the contents of the variable called foo. The variable name may be surrounded in curly braces so as to delimit what is and isn't the variable name in otherwise ambiguous cases. Backslash substitution replaces a backslash followed by a letter with another character. For example, n is replaced with a new line. From Tcl 8.5 onwards, any word may be prefixed by asterisk to cause that word to be split apart into its constituent subwords for the purposes of building the command invocation. As a consequence of these rules, the result of any command may be used as an argument to any other command. Also, there is no operator or command for string concatenation, as the language concatenates directly. Note that, unlike in Unix command shells, Tcl does not reparse any string unless explicitly directed to do so, which makes interactive use more cumbersome, but scripted use more predictable. The single equality sign, for example, is not used at all, and the double equality sign is the test for equality. And even then only in expression contexts such as the expr command or the first argument to if. The majority of Tcl commands, especially in the standard library, are variadic, and the proc allows one to define default values for unspecified arguments and a catch-all argument to allow the code to process arbitrary numbers of arguments. Tcl is not statically typed. Each variable may contain integers, floats, strings, lists, command names, dictionaries, or any other value. Values are reinterpreted as other types on demand. However, values are immutable and operations that appear to change them actually just return a new value instead. Interfacing with other languages. Tcl interfaces natively with the C language. This is because it was originally written to be a framework for providing a syntactic front-end to commands written in C, and all commands in the language are implemented this way. Each command implementation function is passed an array of values that describe the arguments to the command, and is free to interpret those values as it sees fit. Digital logic simulators often include a Tcl scripting interface for simulating Verilog, VHDL and System Verilog hardware languages. Tools exist to automatically generate the necessary code to connect arbitrary C functions and the Tcl runtime, and CritCL does the reverse. allowing embedding of arbitrary C code inside a Tcl script and compiling it at runtime into a DLL module. Files environment modules are written in the Tcl and are interpreted by the module CMD program via the module user interface. Environment modules provides a set of extensions to the standard Tcl package, including setev, unsetev, append path, prepend path, set alias and more, as defined in the module files man page, which, along with the built-in functionality of Tcl, provides a rich environment for handling setting defaults and initializing into an environment. Extension packages. The Tcl language has always allowed for extension packages, which provide additional functionality, such as a GUI, terminal-based application automation, database access, and so on. Commonly used extensions include TK. The most popular Tcl extension is the TK Toolkit, which provides a graphical user interface library for a variety of operating systems. Each GUI consists of one or more frames. Each frame has a layout manager. Expect. One of the other very popular Tcl extensions is Expect extension. The early close relationship of Expect with Tcl is largely responsible for the popularity of Tcl in prolific areas of use such as in Unix testing, where Expect was employed very successfully to automate telnet, SSH, and serial sessions to perform many repetitive tasks. Tcl was the only way to run Expect, so Tcl became very popular in these areas of industry. Tile, TTK. Tile, TTK is a styles and theming widget collection that can replace most of the widgets in TK with variants that are truly platform native, through calls to an operating system's API. Themes covered in this way are Windows XP, Windows Classic, Cortana Aqua. A theme can also be constructed without these calls using widget definitions supplemented with image pix maps. Themes created this way include Classic, TK, Step, Alt, Revitalized, Plastic and Ceramic. Under Tcl 8.4, this package is known as Tile, while in Tcl 8.5 it has been folded into the core distribution of TK. Tix. The TK interface extension is a set of user interface components that expand the capabilities of Tcl, TK and Python applications. It is an open-source software package maintained by volunteers in the Tix project group and released under a BSD-style license. ITCL, INCR. TCL is an object system for Tcl, and is normally named as INCR TCL. Tcl-lib. Tcl-lib is a set of scripted packages for Tcl that can be used with no compilation steps. Tcl-lib. Tcl-lib is a collection of utility modules for TK, and a companion to Tcl-lib. Tcl-UDP. The Tcl-UDP extension provides a simple library to support user datagram protocol sockets in Tcl databases. Tcl Database Connectivity, part of Tcl 8.6, is a common database access interface for Tcl scripts. It currently supports drivers for accessing MySQL, ODBC, PostgreSQL and SQLite databases. More are planned for the future. Access to databases is also supported through database-specific extensions, of which there are many available.